Hi everyone, my name is Jose and I'll be representing Team Lifeline. During this demonstration, I wanted to go over some of the capabilities of our medical device known as the Predictive Pulse Oximeter. Traditionally, pulse oximeters make use of a red and infrared LED accompanied by a photodiode in order to calculate the heart rate and blood oxygen saturation of the patient in real time. Team Lifeline wanted to make modifications to this system by introducing a predictive element using machine learning. The predictive pulse oximeter will predict the risk of hypoxemia of the patient at any given time. The predictive pulse oximeter can be broken into four major subsystems. The pulse oximeter controller, which the user will wear and which will take the measurements, the base station, which will act as the central database, the machine learning algorithm, which will predict the risk of hypoxemia in the patient, and the web server, which will act as a graphical user interface.
The pulse oximeter controller will begin by initializing a Wi-Fi connection to the access point established by the base station. Once connected, the pulse oximeter controller will connect to the base station as a TCP client. When the patient puts his or her finger on the sensor, the pulse oximeter controller will begin taking measurements and automatically calculate and transmit heart rate, SpO2, temperature, and alarm data to the base station every second. This can be seen by the following print statements.
The base station communicates with the pulse oximeter via a bridged access point. Because of this bridge, the base station still has access to the internet while connected to the pulse oximeter. Once the base station receives live patient data, the machine learning algorithm determines the likelihood of a hypoxic event. To communicate with the machine learning algorithm, the base station application uses the CPython API library. This creates a Python environment inside of the application to run the machine learning module.
The machine learning training model implements a linear classifier algorithm which uses a large data size of 50,000 samples for both testing and training purposes. The data is extracted from an online clinical database and synthetically generated using known correlated attributes.
The synthetic data generation includes attributes such as age, BMI, temperature, and the SpO2 level of the patient.
If the chance of a hypoxic event is high, then the base station and pulse oximeter will alarm. The data is logged locally and then sent to the web server after a predetermined number of measurements. The base station communicates with the web server via an HTTP PUT request.
Once the web server receives the data, it's stored into a database along with patient information for user access and potentially for further data processing. From there, the user can access their dashboard and see a near real-time view of heart rate, blood oxygen saturation, and patient info. They can also select from a list of timeframes and see trends over time. In this way, the web interface works in conjunction with the onboard alarms to provide users with feedback about historical and current trends. So in conclusion, we hope that a predictive pulse oximeter like ours makes its way into the clinic and consumers' homes. Thank you, and go Lifeline.
Go Lifeline.
Go Lifeline.
Go Lifeline.